Hello there. Good afternoon, good evening, good morning, based on where you're at. And welcome to our 50 days Kubernetes challenge session. Let me just walk you through what we have covered so far, and we will get started with today's agenda as well. But I would like to welcome everyone in the Zoom room. So I see Guru Prasad, Srikanth, Rohit, Anwar, Gokul, Guru, Kehinde, Lotana, Pradeep, Prashant, Shikha, Shubha, Manuel, Vamsi. If I missed any of your names, welcome everyone, and welcome to the 50 Days Kubernetes Challenge. We're on the mission number 7 today, and we have covered. So let me just walk you through our journey so far, and then we will get started with today's agenda as well. All right, so these are our missions. In total, we have 8 missions. We are on the mission number 7 right now. And we started with the first mission, let's say with mastering the art of writing Docker files. And that was our first topic. And let me see if I can focus on this. Yeah. So that was our first topic, first mission. And then we learned how to deploy the microservices stack split Docker Compose. We learned how to design, deploy, and troubleshoot pods in Kubernetes. So we set up the Kubernetes cluster at that point of time. We learned how to make the applications high available and scalable using the concept of replica sets, replication controllers, namespaces, etc. We also looked at how do you connect the services together using Kubernetes services, different types of services, node ports, and the services under the hood, which is one of the important topics. We looked at how to deploy an application yesterday, last week. That's what we talked about. How do you deploy the application? What is a Kubernetes deployment? How do you build a zero downtime deployment, as we call it? That's the rolling update. What is possible with Kubernetes? What is not? Around the same time, we talked about additional controllers, which include stateful sets, daemon sets, cron jobs, and jobs. This is our second last mission. So this is our second last mission. We're talking about managing data persistence in Kubernetes. And this is going to be very, very useful for you when you are starting to, let's say, deploy an application which requires volume, which requires persistent storage. It could be your database, it could be a stateful application, it could be anything which requires maybe a shared storage, maybe an exclusive storage, and so on. And how is that managed in Kubernetes is what we are going to look at, right? And that's what we have on agenda today. And there'll be multiple objects that we would be looking at today, including persistent volumes, persistent volume claims, how do you mount it in the deployment pod spec, and what is a storage class, what is a provisioner, and how does it all work. Today's mission is going to be quick, though, not too much. So we'll probably be done in an hour or so is what I'm expecting today, right? So let's get started talking about this week's agenda that is about persistent storage. But are there any questions from anything else that we have talked about earlier so far? If there are any questions, I would like to take it quickly, or else we will move on quickly to the storage related topic and specifically talking about the persistent storage, persistent volumes, etc. Yeah, so any questions from earlier related to deployment pods, Kubernetes in general, anything on that line before we start with today's topic? All right. So let's get started with today's topic. So we are going to talk about the storage and how do you mainly dynamically provision the storage is going to be the key part here, because what you otherwise have is you can create the volumes, or you can just create mount something which is available on the local host. using the volume and volume mounts in Pod Spec. We would look at that, but the key agenda here is how do you dynamically provision the volumes and the storage, and that is where we will be talking about all of these concepts. Right, I'm just going to put all of you on mute since there is a lot of background noise. So just make sure that if you are not speaking, you are on mute by default. Otherwise, it might disturb everyone else. Right, so let's just be mindful about that. Perfect. Thank you. So let's get started with, I'm going to play a short video which talks about how storage works in Kubernetes. And then I'll start explaining these concepts. And then I will be demonstrating with one quick example right here. Right. So just give me one quick moment to bring up that video, which we are going to play to understand the storage concepts in Kubernetes. All right, here we go.
And let's go over the Kubernetes storage model. So with Kubernetes, an administrator has to create persistent volumes in a pool. So a persistent volume is a base abstraction for a piece of storage. So it has a size, and it's backed by something like NFS or iSCSI or Google Cloud or whatever. A developer now who needs some storage will submit a persistent volume claim, which is a request for a certain amount of storage. And then they will reference that claim in their pod. And now Kubernetes can match up the exact volume with whatever the pod needs. So this is so far so good. The problem with this is that this requires the admin to provision these volumes in advance, which is not how we think of other resources like CPU or memory. So what if you want to just create those volumes on demand?
All right, let's just understand these concepts first. So what do you do if you are a developer, if you're a user? What do you need to do in order to get a persistent storage? And this is where we are talking about the persistent volume claim and the actual persistent volume, and someone has to come and create that volume for you, right? Now, at a very basic level, you can also, let me show you the code. You can also just create a volume using a local storage and mount it. And for that, there are a couple of primitives that go as part of the pod spec. And let me show you what that would look like. All right, so if you look at the pod spec, there are two things that you would find here. One is a volume, where you define the volume and a specific type of a volume. This could have been a host path, could have been an empty directory as well, if you did not require to connect to an external storage or additional storage and all that. So you define the volume in the pod spec. This is the pod spec. Just like containers, there is volumes. And then you take that volume, let's say DB vol, and mount it on inside the container. So this is a container spec. This is one specific container. And in the container spec, what we do is we reference the volume, that is DB vol, and mount it at a specific location. In this case, this is the destination varlib PostgreSQL data. That is where the volume is being mounted on, right? That's the ultimate destination or location where the container consumes it and uses it. But when the data is being stored there, it is being stored in a volume, and the volume can be of different types. There are many different types of volumes. But when you actually need storage, you go beyond this, and you in this spec, actually, you will see there is a reference to something called as a persistent volume claim. Now, how does this work? How does the volume provisioning work? Let me explain that by dividing Kubernetes into two different planes. One is from the user's point of view, user plane. Second is the administrator's plane. So a user writes the pod spec, maybe as part of a deployment, and that is where the user defines the volume, let's say data, and then references it in the volume mounts. So volume is defined here, and then it is referenced in the volume mounts for container. That's the ultimate consumer of that volume. But when you want to provision a volume, how do we request for it is you reference to something called as a persistent volume claim. Persistent volume claim is like an insurance claim, right? So let's say you bought an insurance, a car insurance, and you got into an accident. You survived that accident, fortunately, but you still hit your car, right? Damaged your car. So you would have to create a claim, an insurance claim, and provide them the details of the damage and the reason and the details and the costs and everything, right? And then an insurance administrator would look at your claim, process that claim, and give you the certain amount and give you the reimbursement or whatever it is for that particular claim, right, associated with that claim. So similarly, when you need a volume, you create, as a user, you create a claim. Right? So what does become part of that claim, or what goes as part of the claim, right? So first is the kind of volume that you want. So the volume type, right? So second thing that you add to the claim is how much of storage do you need, how large the volume should be. And then finally, you can also define the permissions, the modes. It could be either read, write many, as in could it be made available to multiple pods, and can multiple pods read and write to it, or multiple nodes rather, in this case. Read only many, so it can be made available to many pods and made available as read only. And read write once. Read write once is more like an exclusive exclusive volume, and only one pod would be able to read and write to it, right? And this is actually based on the node, basically, right? Because when you say read write many, it is basically made available to multiple nodes, and then in turn the pods available on those nodes. So, but this is what goes as part of the claim. So first is the type of storage that you want, how much, the size of the storage that you want, and the permissions including either of these three, basically. So you create a claim, and then the administrator, just like how I mentioned about the insurance claims, and an insurance administrator has to process that claim. Someone has to process that claim, and typically a Kubernetes administrator, DevOps person, or whoever is responsible for administering the Kubernetes cluster would have to typically create the volume for you, right, on demand. So when you ask for a claim, you have to either wait for someone to create the volume for you and be associated with that claim, or the administrator has to create the volume in advance and keep them available in order for this to work immediately. Otherwise, what could happen is you would have to wait for someone to come in, intervene, and create the volumes for you, and only then will your pod be running, go in a running state, right? Otherwise, it will be just waiting for the volume to be available. Now, this is not how we do things in Kubernetes otherwise, right? So if you want pod with containers with certain amount of CPU and memory, you don't have to wait for someone to assign those many resources to you. This is dynamically done. But in case of volume, it was not dynamic up to certain point of time, right? And that's what that's what was mentioned in the video, that it used to be like this earlier, where developer had to wait for the administrator to come in and provision the volume. And that is when, let me replay that part.
Whatever the pod needs. So this is so far so good. The problem with this is that this requires the admin to provision these volumes in advance, which is not how we think of other resources like CPU or memory. So what if you want to just create those volumes on demand? So the alternative is called dynamic provisioning, and that's done with storage classes. So instead of the admin creating those volumes directly, the administrator will create a couple of different profiles of storage that they want to provide. So let's say fast storage is always provisioned on SSD, slow storage is provisioned on hard drives. Now a developer does exactly the same thing. They claim, or they submit a persistent volume claim, but that volume is only created at the moment that that claim is submitted and then attached to the pod. So for Kubernetes, this is the base model of how you do storage.
All right. So with the storage, I see a couple of questions in the chat. I'm going to address those in a few minutes. Let me first explain the entire topic and the workflow here, right? So what is a storage class now? So storage classes were created to solve this problem of you waiting for the administrator to provision the volumes. So what happens with the storage classes? So storage classes is what is defined by the administrator. It's like an automation for creating the volume. And once the storage class is defined, and let me show you some examples of the storage classes. Storage classes allow you to provision the volume dynamically. That's the whole purpose of storage classes. So let's say this is my storage class, or these are the storage classes which are supported by Kubernetes. And if you define a storage class, it would dynamically provision the volumes, provided what kind of provisioner is available, right? So some storage classes have internal provisioner. That's also when, so you see a list of storage classes that are supported by Kubernetes. That's one, right? So this is a list. Secondly, you see the second column, which is also important, which says internal provisioner. If there is an internal provisioner, what happens is Kubernetes already has the code to talk to that storage system and provision the volume for you. For example, if it is cloud like AWS, EBS, or a file, you just define a storage class like this and you're done. I mean, you need Kubernetes to have an authorization to provision the volumes for the cloud, of course, but otherwise, you don't have to run any additional provisioner or such. You just define the provisioner. Provisioner is internal to Kubernetes, and you don't have to do anything else apart from, providing the authorization there. It will automatically provision for you if there is an internal provisioner. So internal provisioner is like an automated provisioning. Now, what if you do not have an internal provisioner? And in such scenario, and if you look at an example such as CephFS or NFS or iSCSI, right? There are no internal provisioners available. So what you do in that case is you have to launch a provisioner which runs within the Kubernetes cluster. The provisioner runs as a pod inside the Kubernetes cluster, and that listens to the persistent volume claims, PVCs, and then interfaces with the storage system and creates the volume for you, right? So the provisioner will actually go and provision, as in create the volume, and those volumes then will be given to the persistent volume claims and then made available inside the pod. Now, another question is why to use a persistent volume claim? Why not directly mount it in a pod and just make it available to the pod, right? So there are a lot of interesting scenarios here, right? Because one is you may want to share the volume across different pods. So in such scenario, again, having that associated with the claim is better, because then you can connect to that claim from different pods. And if it allows you to use RWM or ROM, as in read-only many or read-write many, you can make it available to different pods on even different nodes, right? So that's number one. Secondly, what happens when you're deleting the pod and replacing it, right? Because if you are talking about rolling updates and whatnot, the pods will get deleted and be replaced with the new pods altogether. In such scenario as well, having that volume associated with something else apart from pod is very useful. So it is a very flexible way of associating the volume, and the volume will be there even if the pod is not there. Even if you delete the deployment or a pod, the volume remains till the claim exists. So it is associated with the claim, and then you can mount it in a container within a pod or multiple containers within a pod, right? So there is a question here related to that. Michael asks, all containers in the pod, can all the containers in the pod read write to the volume? That is possible, depends on how you have mounted it. When you, it's the volume mount configuration basically that will drive it. And if you have mounted it in multiple containers and made it available to read write, it is possible to have it be written from multiple containers. When you mount it, you also have an option to just make it read only as well. And this is, again, a lot of these things go back to the Kubernetes API's preference, right? So as I told you earlier as well, you should be very conversant with the Kubernetes API reference document. And this is a spec which would be part of the container spec. So it will be part of the container spec actually. And within the container spec, you are going to see the volume mount somewhere here. And within the volume mount, you can say, oh, I just want to make it read only. So that's possible. By default, it's not read only, but you can make it read only on a specific container. Let's say you have two containers in a pod. One writes to it, second is read only. So when you mount it on that second container, you will specify the volume mount read only option there. Right. So that's the answer to that. All right. So there was another question. PV exists in cluster like any specific node. So it depends on persistent volume. Where does it exist? That's the question from Sandeep. Does it exist on a specific node? That really depends on the kind of storage that you are going to use. For example, if you use a storage of type which is Elastic Block Store, it exists on none of the node. It is a network storage. Same with Azure Disk and so on, CephFS, NFS. So if you're running NFS, for example, on one of the node in a cluster, then it would be on that node. Otherwise, it might just be an external storage system as well. There are certain types of volume. If you use local, of course, it would be on that specific node. The example that we are going to use would be a local provisioner. So it would be on a specific node, but otherwise, if you use a cloud storage, if you use a network storage, it would be available external to the nodes and can be mounted and made available to the nodes as well. So it really depends on what kind of storage that you are using here, right? But the concepts remain same. So you have these concepts that you should know about when it comes to storage. First is the storage class. Storage class is like a configuration created by the administrator for setting up dynamic provisioning. The actual provisioning of the volume is done by the provisioner. Provisioner can be internal, meaning it is part of the Kubernetes itself, or it can be external, where you have to set up the provisioner to set up create the volumes. The persistent volume is the actual piece of storage, and it has a size, it has a type, and you can define the permissions on that, how you want to attach to a specific node or a pod. And then that volume gets associated with the persistent volume claim or the PVC. And then the PVC is what is referenced in the pod, and then pod and the PVC are kept separate because then PVC manages the volume. PVC is where the volumes get attached. Even if you delete the pod, it will be there until you delete the persistent volume claim. So it is flexible. You can associate different types of volumes based on different PVCs as well in different environments. So it's quite flexible this way, right? These are the concepts that you must know about when it comes to the storage in Kubernetes, persistent storage in Kubernetes, right? And these are the storage classes. There's something else also, like when I spoke about internal provisioner, Kubernetes comes with this code to interface with these many storage systems. Now, this is not how Kubernetes wanted to do things long term. So now they're moving to something called as a CSI. CSI stands for the Container Storage Interface. If you're aware how Kubernetes interfaces with runtimes, it is via a interface, Container Runtime Interface, or CRI. Similarly, it is trying to get to a mode where they don't want to maintain the storage code and interface with the storage from within the Kubernetes. They'll create a CSI, meaning there's an interface, and anyone who is compliant with the interface can talk to Kubernetes on the fly. And that code will be maintained by the respective developers of those projects, not Kubernetes, right? Because right now what happens is, even if there is a bug fix or a new feature to be added to a specific storage system, you have to wait for the next version of the Kubernetes to be released in order for that to be available to you. With CSI, that will be flexible, because then even with the current version of Kubernetes, the CSI can get upgraded. You can install the new version of that and start using those features. And then it is maintained out of band to the main Kubernetes development, right? So that's the model which is coming in right now. And slowly and surely, Kubernetes is, every release, they're moving certain provisioners outside and making it compliant with CSI, right? So CSI is the next thing which will happen in future, and based on that you can basically write any storage and make it compatible with Kubernetes by just creating a CSI compatible code and interface with Kubernetes there, right? So that's the idea. Now any questions on any of these concepts that I just spoke about, the objects that I spoke about, storage classes, provisioners, users, the pods, persistent volume claims, and the persistent volume. Any questions related to that? All right. Let me explain this a little more with the properties in Kubernetes. Let me see if I can find out my mind map from here. All right, so I have it as part of my documentation. I'll explain it from there. So these are all the concepts, right? So that you should know about. I have already spoken about some, so I'm just going to summarize it. So in the pod, you have volume, and that will be referenced in the volume mount within the container. When you talk about persistent volume claim, what do you define? The three main things is what kind of storage class, that is the type of storage that you have, the size of the storage or the volume, and the access permissions, which could be either of these three: RWO, RWM, ROX, or RWX, like read only many, read write many, or read write once. As an administrator, you can also define a limit range. Limit range is kind of a cluster configuration or an admission controller, which would allow you to create a volume only within that particular limits, right? So minimum and maximum. You can say that, oh, minimum volume you can ask for is 100 megs and maximum is, X amount of maybe 5 terabytes, or maybe, 20 gigs or 200 gigs or whatever. So you can define those as limits as in the form of minimum, maximum, and this is cluster-wide configuration. You can also define persistent volumes. In that case, you have the pump. You have few configurations with the persistent volume. Persistent volumes has these many status, so it can be available, it can be bound to the persistent volume claim. It could be in a release state, or it could be in a failed state if there is an error. You can mount it as a raw block, in which case you have a choice of formatting it from the pod and container using any kind of file system that you want, or it could be just a file system, which is the typical way of mounting it. And there are some beta features, probably they've stabilized now. One of that is volume snapshot. Again, this depends on the kind of volume it is. For example, if you're using AWS EBS volume, it can be snapshot, right? So you can create a snapshot of that, and that is possible right from the Kubernetes as well. And storage classes allow you to have a dynamic provisioning, and the provisioner can be either internal or external. Internal comes with Kubernetes, external you have to run external pod. And then you have a reclaim policy, meaning what do you do with the volume when the volume claim is deleted, right? So whether you retain it, whether you delete that, whether you recycle it, recycle is gone. So either you delete it or retain it, depending on what you want to do with that volume and the data inside that volume, right? So that's about the Kubernetes storage concepts. And let me now demonstrate this to you by creating a pod and an application, a database application here. So it is, again, we're going to go back to the same application that we have been talking about, the microservices application stack here with 5 services. As part of the previous missions, I've shown you how to deploy the boat application, connect it to Redis, and so on. Now, I'm going to take an example of the database, which is the PostgreSQL, and this requires a volume. And I will show you by provisioning a volume and creating a storage class to do so as well, right? So let me begin by demonstrating that part. So it's going to be for the database. Database requires a volume. I've shown you the code, a little bit of that earlier. So it's the same. It's a deployment for the DB, which would run Postgres. You see the labels here. You see the data spec here. And then the volume here. This uses a volume. So volume is called as DB vol. This is the name of the volume. And what configuration should be used to create the volume? It is all part of the claim. So I'm just saying that reference this claim to find out the details of this volume. So DB PVC is going to be the claim that it will look at. And once the DB volume is available, it would then be mounted. This is the container. And to this container, it would be mounted at this location, varlib PostgreSQL data, right? So it would be available here on that container once it is mounted. Now that is what this deployment looks like. And I'm going to start watching for a few things, right? So I want to show you this whole deployment and how it works. So I'll be watching for storage classes. I would be watching for persistent volume claims, and all of those basically, right? So let me start the monitor part here. So I'll be watching for pods, persistent volume claims, persistent volume, and storage classes. Storage classes has a short form now called as SC. So I'm watching for all of this. I have none right now. Let me first begin by creating the deployment. Deployment will launch the pod here. So DB deploy PVC. I have to first create a namespace. This is a new cluster that I've created. So I have to create and switch to the namespace as well. So let me first create the namespace and switch to it. All right, so I have applied this deployment, and that would have created a pod called as DB. Now this pod is in a pending state. When we talked about the pods, I've spoken about 3 different types of issues that you may encounter. One is pod in a pending state, pod in image pullback off error, and crash loop back off error. If it is in a pending state, what should be our course of action? Where should we find the issue? Or what should we look at? Any clues? Anyone? You can put it in the chat as well or speak up.
Describe.
Describe, exactly. So it's
describe the pod.
Describe the pod whose name is this. And look at the events, basically. You can also look at the events. And this is where it tells me who gives me that information is the scheduler. What does scheduler say? I could not schedule it. And it tells you the reason why. Why? Because in this case, it could not find the claim, because we are referencing a claim in the pod spec, but the claim doesn't exist. And that's why it says persistent volume claim DB PVC not found. So I could not schedule it because of that. Now, what do we need to do then is to create the persistent volume claim. So how does it look like? What goes in the persistent volume claim? Let's look at that as well. I already have a claim file here, and there are 3 main things. One is the kind of storage. There's a storage class name. How much? That is part of the resource specification. I'm saying 2 gigs. This is where you define how much volume you need, right? And it's a dynamic provisioning. If it is dynamic provisioning, it would automatically create the volume with that size. All right. So there is a question from Nikhil. What is the default storage used in Kubernetes? There is no default storage. You have to create it. There is a local provisioner. There is host path. There are empty directory. There are storages available locally. But otherwise, you have to launch a provisioner and create a storage class, which is default. As you can see right now, I'm listing the storage classes. There is none right now. So there is no storage class yet being created here in this cluster specifically. There's no default storage. But I can use local volumes anyways, right? So let's say I wanted to create an NFS. This is typically what I used to use. but it has started failing with the recent version of Kubernetes, right? 1.24 onwards. So I'm yet to fix it. So I would be using a local path based storage and create a provisioner, but it would be a local path based storage. So instead of NFS, I'm going to change it to local path. So what kind of storage? It's going to be local path. This is not how you do it in production because local path will be specific to a node. Typically, you would have a cloud storage or a network storage. Since NFS is not working right now, I'm going to resort to local path, which is my backup fallback. So let me create the claim now. So I'm creating the DB PVC persistent volume claim. You do see the claim created in the bottom monitoring window that I have opened. So there is a pod which is in pending state. The claim has been created. Pod was pending because it couldn't find the claim. Let's find out now what it says. Because scheduler keeps on, it will always attempt to fix the issues and it will try to create the pod again once it sees that the claim is available. So let's see what happened now. So kubectl logs and the same pod or describe rather, which gives me the events. So describe has to take the type pod. And now it says earlier it said there was no persistent volume claim. Now it finds the claim, but it still failed to schedule because there is no volume bound to that claim. I just have the claim, right? Just the claim is not enough. You actually need a provisioner or a volume to be provisioned, and the volume has to be associated with the claim. Only then will this work fine. So there is no volume which has been bound. It's not found. So that's why this fails now, right? So that's the second problem. Now, what do we need? We need a volume to be created. So how do we create a volume? We have two options. Either we create it by hand as an administrator and associate it with the claim, but we don't want that. We want it to be provisioned automatically. So if you want it to be provisioned automatically, you need some sort of a storage class and the provisioner for it, internal, external, whatever. So I'm going to launch that storage class and let it provision automatically here. So how do I launch the storage class? Again, I had that NFS storage class, and now it does launch it, but then there is a problem later on. So I'm not going to use NFS. So I'll just use a fallback storage class called as a local path. So this code will deploy it, and you see now a local storage class created, a storage class called as local path created, and it has some configuration and here and so on. And since where does it get created? Let me show you that. Get pods -n. I think it's a storage namespace or one of that. So I will. Okay, so there's a local path storage. It's a pod running in the cluster, provisioning for the volumes. And earlier there was no volume. Now you do see the volume which has been bound. So this persistent volume claim says now bound, and then pod is now in a running state. So what all happened? The volume got created. Who created the volume? It was the local path storage, this provisioner rather. If I look at the logs, maybe I will be able to see it most likely what it did. So what does the provisioner do? Provisioner is constantly watching for the claims. So you may see that in the log that it found a claim somewhere. And okay, it says a volume has been created for this claim. So yes, so probably somewhere it found the claim. So it's creating the volume for the persistent volume claim. It says that. So it says provisioner started. Right, so the provisioner started here, and then it found the persistent volume claim PVC, and for that it started creating the volume, and then it associated that volume with the claim, right? So that's the whole configuration that it did, and that is when this volume was created. If you look at the volume, it was created with the exact configuration that I needed, like 2 gigs of volume, like that's the storage I wanted. read write only once. That is the permissions that I wanted to set on it. Reclaim policy is delete. So when the claim will be deleted, the volume will automatically get deleted. It has been bound to this persistent volume claim. Since the volume is available now, this comes up. So if I go back and look at the events for the pod, it has done the provisioning. So earlier it was waiting, and then it said, oh, now I could assign it you to this particular node, and then it started pulling the images and running everything else, right? So now that it has a volume, it has been launched, and the pod and the container within that is also running. Again, this is just a local path provisioner, so it is, you know, on one specific node only, but ideally you should be using something which would be available on multiple nodes, possibly some sort of a cloud storage, network storage, and that's when you would explore the storage classes which are given here. Right, so one of these storage classes is what you typically use, not just the local, but you have many other storage systems, and there could be many others which would interface with Kubernetes using the CSI, which is the container storage interface, that is. Right, and that's what I wanted to demonstrate to you. So as I told you, it's a quick demonstration today. We are talking about purely just these objects, which are persistent volume claim, the storage classes, provisioners, and how the dynamic provisioning happens. And this is all dynamic, right? So it just got created automatically, and it automatically provisioned. And now that I have this in place, if I create a persistent volume claim and use it in some code, it would be automatically created and bound to the volume claim, and would be made available to the pod that requires it. Right, and that's all really. That's what I wanted to talk about in terms of the storage objects and managing persistent storage in Kubernetes. And probably just one more thing that I would add here is, how does the storage work for different controllers, right? Because that is important, I think. Because what happens is, if you use deployment will typically work this way. With deployments, you are going to have storage or volumes which would be shared. So there'll be one volume and multiples of pods will share it. Now, this may not work with databases, and this is also the reason why you should be using stateful sets, because what happens with stateful sets is, in case if you're running this as a stateful set, let's say 3 databases running as 3 pods, which are launched by the stateful set will not use a persistent volume claim, but rather it would use a volume claim template. Just like pod template, it has a volume claim template. And if it is a volume claim template, it would automatically create a volume for every single instance of the pod. Every single instance of that application, every single pod will have its own volume, not like a shared common volume across multiple pods. And that's one of the key differences between deployments here and stateful set, STS, that is. All right, I'm just going to look at some of these questions from the chat as well. So I've already answered the question whether volumes exist. It depends on the storage classes. And another question about the read write, and you can selectively mount it read only as well. There's another question by Pradeep, which says, can you also explain empty directory concept and what are the use case scenario for using it, right? So the empty directory depends on, okay, so empty directory is like a temporary storage, an ephemeral storage, and you can use an empty directory even without persistent volume claim, etc. And empty directory is a temporary storage, which is basically when you create a pod on the same node, it would basically use one of the paths or one of the directories. And what this is really useful for is empty directory is, let's say this is your pod and this is your container 1. This is your container 2. Let's say container 2 adds the files which need to be accessible by container 1, right? A lot of times when your application needs some data which is somewhere else, you launch an init container. So even before container, you can also launch an init container. And init containers job is typically, this is very useful use case for init containers. So init containers come in before your actual application containers run. They are for initialization. And one of the steps in initialization could be, hey, fetch the data from this place and make it available in the volume, which then be available for your application. How do you do that? Use empty directory, fetch the data from wherever you want and put it in the empty directory. Init container goes away, gets exited, goes away after adding the data, and your application container comes up. When the application container comes up, it mounts the same empty directory. And empty directory is shared across all the containers in the pod, okay? Because when you talk about pods, and all the containers in the pod would have access to whichever volume you have given to the pod, and you can selectively mount it. I mean, it's not must that you mount it, but you can selectively mount it and make it available. So empty directory is a very useful thing to have in such scenarios where you're sharing data between two different containers within the same pod. And the perfect way to do that is just use empty directory. You can also initialize the data before your application comes up. Any practical demonstration for stateful set use case? Let's see if we can find one. So practical use cases is typically, I mean, your databases, right? So let's say you want to run Cassandra cluster, and you would want 3 nodes to be created. Each of them should have its own volume. And it's stateful set is ideal for that. Plus for Cassandra, what also happens is every other node, this is your node number 1, every other node has to connect to node number 1 to fetch a key or a token, which is then used to configure something called as a Cassandra ring, for example. And stateful set is useful there again, because you can identify the first node. In deployment, you cannot identify, oh, this is my first node or this is second node. Everything is randomly organized and the names are not very predictable. With stateful set, it uses 0, 1, 2, and so on. So let me see if I can give you an example of that with a volume claim template. So I think in Kubernetes examples repository, there was some code for Cassandra as a stateful set, if I remember right. If it is still available there and if it works, I will show you a demonstration of that. This is Cassandra. This is a stateful set for Cassandra. It uses a volume claim template. It's not just a volume claim. Observe this. It's a volume claim template, right? So let's see if this works. I'm going to attempt to launch it. It's been updated 4 years ago, so I'm not sure if this still works, but let's give this a try. Okay, so let's clone it. And I'll go to Cassandra. I'll switch to just update the code to use the storage class, which is available locally for me. You can also have a default storage class. Now, this has not been set as default because I don't see that configuration here yet. So I have to update the stateful set to use the storage class that I want, which is local path. So it's going to be in the volume claim template is right here. Storage class is local path. Let me give this a try. So a stateful set needs a service. It's a prerequisite for a stateful set because it will identify each and every pod with a specific name. So it needs a service and stateful set. You see Cassandra 0, it's in pending state, probably waiting for, has it created the claim? It has created the claim. It is bound. You see, it's automatically provisioning. This is dynamic provisioning. Oh, this is fantastic. And you see stateful set, it is creating it one pod at a time. It's always gradual. It will have a predictable name. So every instance can identify Cassandra -0 in that namespace. And that is very important. I mean, there is an error. It's running. So maybe there's something which might need to be fixed. But otherwise, if it goes fine for some time, it is going to launch the next one and the next one and the next one. If I have, multiple instances, that is, let me check what is there as defined as the number of replicas. Replicas is 3. So it will launch 3 if it works fine. Since there's an error, it might have a problem. So it may not, but at the minimum, I could show you that it creates a persistent volume claim template. And even that template, the claim is created with -0. And when it goes to the next one, it would be -1 and -2 and so on and so forth. It is crashing because of the application issue. Let me see if I can just use some mock application instead of Cassandra. We're not doing anything here so specific, so that might just work. Trying to use something else then. So let's just say use this image, Nginx. Yeah, you can do stuff like this. We're just doing a smoke test. So yeah, I also use some troubleshooting, security troubleshooting labs where we actually intentionally change the name of the image and so on. So it gets interesting when you do these kind of things, try these kind of things. So, all right. Should I really replace this? Just gonna do it. Okay, it has done it. Right, so it is running. So, okay, let's find out what is going on. Kubernetes logs. Yeah, there's more to it. There's some configuration problem. Of course, that's going to fail. So there is something else. So there is probably some command and everything overridden as well. So that may not work. It will just take longer. But I just wanted to show you how this would work anyways. Let's see if we can fix it quickly. There's the container image pool policy, resources. Yeah, it's the command which would of course not run. Yeah, I didn't miss something else. Okay. All right, let's just keep bare minimum thing and hope that works. It tries to self-heal. I can also delete it so that it anyways creates it again. You do see it launched again. It's a controller, so it can watches it in the control loop. It is creating because it's pulling the new image now. And yes, now that worked, that trick worked. So after it got created, it launched the new one. And for that, it created a new persistent volume claim as well. So there's a template and it created the claim. And now it also would launch another one. So 3 in total. It's not an actual Cassandra application, but if you fix it and make it work, that would actually give you the database as well. But I wanted to show you from the how stateful sets work, that point of perspective, plus how stateful sets work with the volume, and each instance will have its own specific exclusive volume. Unlike deployment, because deployment just uses volume, persistent volume claim, but stateful set has a volume claim template. So even that is templatized. So every instance of the pod will have its own exclusive volume. That's one of the key differentiators between deployment and stateful set, which is not talked about a lot, but that's a very important difference in my opinion.
I got a quick question there. How does it make sure that all the three volumes are in sync? Because if I update the database
That's
from
at the
one,
application level. So it doesn't have to be in sync in this case. In case
Okay.
of Cassandra, if you have a replication factor, you have every information will get replicated twice. So not everything is in sync. So it will happen at the application level. That's number one. So it has nothing to do with the way Kubernetes operates, and Kubernetes has no role to play there. And if you create three databases, for example, three MySQL databases, it doesn't mean that it is always gonna remain in sync unless you set up a MMM replication of MySQL. It will not work. So in certain scenarios, it will not work for you. If you have independent databases like three instances of Postgres with some random data there, it won't be in sync by default, right? But this is Cassandra, which is NoSQL database, and Cassandra is designed in a way that it can form a ring, as in it can form a cluster, and then it can replicate the data internally. So that happens at the application level, not at the volume level, not at the Kubernetes level. So that is absolutely application dependent.
Got it. Yeah, thank you.
All right. I hope that answers.
It does. Thank you.
Sure. Anything else? Any other question with?
Yes. One thing from mine. Yeah, may I know the major difference or use case between stateful applications and stateless applications in Kubernetes, which are mainly used? Yes, you said the main difference between stateful and the deployment, right? That means pushed volume and pushed volume claim. There is the same difference between the stateful and stateless application. May I know that?
So a stateful application has specific data on a specific instance of that, let's say a specific instance of an application, right? So there is something here. So stateless application is basically, let's say you have a front-end web application, web server, and stateless application just comes up and it doesn't store any specific data that you would need and it's critical on top of these instances. It is stored outside of that. So could be, how do you make application stateless is, okay, if you have a session information, user session, the user login and there is a session information. If you want to make it stateless, you move that session information outside of your web servers and put it on some caching server here, like Redis. Similar with the storage, if you're sharing the files, all of these will mount this file, all of these will connect to this, for storing session, it connects to Redis. For sharing data, it connects to NFS. That becomes stateless. So you are not dependent on that application or an instance. So if any of this instance goes away, you don't have to bother about it because it's just a compute unit. It just comes up, does some compute, and stores the data, store anything which is going to be useful for you outside of that instance. That is the key property of a stateless application. Stateful application is opposite of that. So with stateful application, you're storing, it's a local volume and you have some information here, right? You have, I mean, with things like Cassandra, you still have like, oh, if this goes down, you replicate the data at the application level. So at least two of them are there, so it will survive. But if two of those go down, you will be in trouble. You will lose data in that case. So you are dependent on those specific instances in a way, and it stores the state on that server. It is attached to that server, maybe volume, yes, but if this goes down, you'll still be in sort of a trouble. So that's the kind of a stateful application, and it needs to be handled in a certain way. And in case of Kubernetes, stateful sets are ideally suited for those kind of application, which require you to have, or you are dependent on a specific instance. You can also identify a specific instance with its own, there is a specific identity of that instance as well, right? So, for example, Cassandra 1 will always be Cassandra 1. For example, in case of stateful set, right? So this will always be called as Cassandra 1, and it would come up on the same node, even if I delete it or update it or whatever. So let me show you that. In case of deployment, that's not the case. Deployment, if I delete this pod in a deployment, it will come up with a new name. So it's going to be a new name. You see, you saw that it changed because this is not the same. In case of stateful set, if I delete this pod, it has a fixed identity and a fixed node. So let's see which node it is running on. So this is running on node number 3, kube03. So if I delete this Cassandra 1, you see it comes back up on the same node with the same name. So it is a constant identifier. Let's do that for 2. 2 is running on kube02, 3 as well. 2 is running on kube02 and with this name 2. Look at the age. It's been running for 6 minutes. I'm deleting it. Now it gets recreated on the same node with the same name. So that is how stateful sets work in Kubernetes, and stateful applications have some data on that specific node that if you lose that node, you might be in trouble. That's the key identifier of stateful set and stateful application versus a stateless application where you don't have to bother about it. The data is somewhere else and you're not dependent on that specific node.
Thanks. Thank you.
Gaurav, one more question on this stateful set. So, I mean, like one of the nodes would be the primary where you can do read and write. So other parts would be just read only. So how do you direct the traffic? Like, how do you identify it's a read only traffic and it's write only traffic? Is it something we have to do, or like Kubernetes will take care of that part?
No, Kubernetes won't take care of it. You have to take care of it. In case of Cassandra, it doesn't matter. In case of applications like Cassandra, that is not the case. It's not like there's only one which is read-only and everything else is not. In this example, you can read and write to any of this. But let's take an example where we have a scenario. Let's take a database, a relational database like MySQL. In that case, I have the primary where I can read, write. And this is read-only replica. This is a read-only replica. Now, how do we scale the reads and how do we decide when it is read operation, you send it to any, maybe set up a load balancer on top. If it is write operation, it has to go to this one. There are a couple of ways, approaches to do this. One is you can do it from your code. You write the code in a way that your reads and writes are going to different endpoints, right? So you can do that. I mean, and you can write the code. It's a work, but you can do that. If you cannot do that, or if you don't want to do that, in case of, again, this is application specific. In case of MySQL, there is something called as a MySQL proxy. And that proxy will receive all the traffic, all the requests, but it has a capability of splitting the writes versus reads. Reads will go anywhere, writes will only go here. So that is done by the MySQL proxy, right? So you have to find something like this for your application and use that, or your application needs to have a capability of sending the reads versus writes to different endpoints. So it is application specific. Kubernetes has nothing to do with that. So it doesn't have the capability of doing this on its own.
Yeah, got it. But the question is, people really use this stateful set for relational databases in general? I mean, like, it's a bit complex, right? If you have like a terabyte of databases, like every time you create a database, every time you create a new pod, it has to duplicate the data into that node, isn't it?
It really depends again, right? So it does, I mean, if you are creating replicas and replication, you have to do, replication is a lot of work, to be honest. But if you're using something like Cassandra, that happens automatically. If you add another node, it automatically set up the replication between those nodes, etcd, Cassandra, MongoDB. Those kind of applications are capable of handling this replication factors and all of those on it. They're built to scale horizontally. So an application can scale horizontally. It is fairly easy to manage it with stateful set. However, I think if you attended the last week's sessions, there was a comment by one of our members saying that they've seen some issues with the stateful set, mainly to upgrade, and it takes forever and it hangs. So there may be some issues like that. Again, you'll have to check it because it keeps on evolving very fast. And earlier it was in beta. Now it has evolved to stable. And so you have to look at it from that particular use case and do it. For relational databases, it is harder, definitely.
Yeah.
And there you have to make a choice. Either you, a best way to handle it even now, especially on cloud, is using managed services. So if you have a managed service like RDS that takes care of replication, multi-AZ, failures, handling, and all of that, which is easier. So in a lot of production environment, I still see something like RDS being used, or databases being managed separately. But yes, so if you have NoSQL, you can possibly try stateful sets as well. Relational databases, you'll have to be a bit careful, and there's a lot of work to create replication, maintain that, and in general, connecting those databases in a multi-master mode as well. It's going to be a challenge for sure.
Yeah, got it. Thank you.
Yeah.
One question from my side: is the database is in container is good for a production environment? That means the database is in container. Is it good for production environment, or else production deployment? It is good.
Yeah, I just answered that. So relational databases, you maybe want to be a little bit wary of that. And NoSQL, you may want to try that, because NoSQL is horizontally scalable, so it is easier to use it. If you use it, you can try it with stateful sets as well. But relational databases may make sense to use some managed service like RDS or equivalent, especially if it is a production environment. Unless you have teams and expertise who can manage it for you, I would suggest you go with the managed service like RDS.
Yes, Gaurav, I think so.
Thank you.
In the relational database, we should go for the RDS kind of thing. And if there's something in memory or like that, we can go for the STS. That can support the production.
Absolutely, especially in production, right? So when your data is critical, that's the way I would suggest, especially if you don't have the dedicated teams who are handling databases and all that, then you may think about it, but otherwise just go with managed database solutions. That's right.
So Gaurav, anything in the stateful set, so which is not replicating across all the pods will be a problem, right? Like Cassandra, by default, it has the it is part of cluster. Or
correct.
So if anything, any database which is not taking care of the replication across all the pods in the stateful pods, then it will be a problem.
Yes, so you have to create a mechanism in a way that you are configuring those nodes. It will be a problem unless you take care of it while initializing, that it is automatically selecting one node as the first node as the primary, and everything else is replicating. So you have configurations like that, by the way. So I've seen a Redis installation with stateful sets where the first node is set as the Redis primary, and every other node gets set as replica of that, right? So you can do that. There is some work, especially init containers and so on, but it is possible to do it. But unless you have that, it is going to be quite a bit of a challenge, unless you have that in place where you're automatically setting up the replication. Even if you do that with certain relational databases specifically, so I've managed replication for Postgres and MySQL, and it is a challenge because you have to monitor it, you have to make sure it is in sync, You have to, test it every now and then, and that you have to reset the replication sometimes. So you will have those challenges. Those are not going to go away just because you're using Kubernetes, really. So those were there before Kubernetes, those still remain with Kubernetes if you're using a relational database. So that's more like a application choice, architecture choice that we have to make.
Got it. Yeah, sure.
Yeah, so Kubernetes doesn't solve all the problems for you. Those still remain. It just maybe scales it up here, with its inherent scaling and so on. So those architectural challenges will still remain.
Like what I explained, anything that can have in cluster or can have, we can create the master step configuration that run easily, but anything that is not cannot make it make like that, no? The data setup.
Exactly. So
Yeah,
I
that
mean,
is the issue.
we can use this as a guideline, as anything which is like horizontally scalable.
Yes.
You think about stateful set. Otherwise, it's better to run it outside of Kubernetes with the managed environment, managed services. That's right. All right. Any other questions? All right, folks. If no more questions, we have a lot of folks today. I would definitely like to see all of your faces. We'll take a screenshot with all of you here. So maybe you want to turn on your cameras. We will be done. We are pretty much done with the agenda. We'll just take a quick snapshot of this group that is going through the challenge, maybe. So can you guys and girls turn on your cameras for a minute or so? Maybe? Yeah, I see Suleiman, Nikhil. Yep. Awesome. Oh, that's cool. That's awesome. Okay, I'm just trying to see if I can take a screenshot, maybe. All right, so let's take, oh, it's not working right now. Hoping it would. Okay, yeah, right, there we go. Yeah, folks, so let's take a screenshot, maybe. Thumbs up, thumbs down, either ways. If you like the session, you can do a thumbs up. If you did not, thumbs down, either ways. All right, I'm just gonna take a screenshot here, stay like that. Bad with technology. I've become bad with technology now. All right. Yep, I think there we go. So, all right. So thank you very much for attending these sessions. I hope it's been a useful journey for you. I have been a little lagging uploading these to that portal, but I would try and do that this time by tomorrow or so. And we have the last mission to complete next week. We are going to talk about the ingress controllers, and that should sort of wrap it up for the Kubernetes challenge that we have. And thank you, and I'll see you next week. Bye-bye. And all the best with your Kubernetes journey.
Thank you so much.
Ask you one question.
Bye.
Yeah, thank you. Yes. Go ahead. Last question.
Yeah, last question. So, Gaurav, so in the persistent volume, right? When we create persistent volume, so we give a host path, right? And then we give the PVC, we give mount path. So that's the mount path for the pod and the host path for the node. So do we need to have can I have a separate volume independent created and can I give a mount path, or I need to have a node and associated EBS or persistent disk with that, then only I can do this?
No, you can create a volume with a local path as well, and then have it be associated with your with a container. You can even create it without the persistent volume claim. You can directly create a volume with host path and empty directory and whatnot, and make it available inside the container as well. So you can do that without PVC. You can do it as a separate volume, persistent volume as an object. You can create it and then associate it with it as well. So it is possible very much.
Okay, sure.
All right. Okay, also there is just one last question. I think the Setu says he's not able to join the Discord channel. I will share the Discord link possibly in the email when I share the recording. And there is something else that I'm working on apart from Discord. So especially for the silver and gold members of School of DevOps, we're going to have a new community, brand new portal, brand new community with a lot of things that are going into it from next month onward. So I'll be reaching out to you, especially if you're a silver and gold member, and we would all be using that community and move to that here. So it's going to be more like a social learning platform that we're moving towards. So that will come in next week. I'm working on it right now. So in the meanwhile, I will share the Discord link as well so that you can join that.
One quick question. Do you have any live DevOps classes by any chance?
This is part of DevOps. DevOps as in, what are you expecting in terms of live?
I mean, live, regular live training classes.
You're talking about in person?
Mm-hmm.
No, I don't do in person right now. Even my corporate trainings are happening live online. So it's completely virtual right now.
No, that's what I meant, live online. So
DevOps as in, you're talking about the CI/CD and other tools and stuff.
Mm-hmm.
Right now, I'm not doing it, except for my corporate batches. I have corporate trainings, which are like exclusive to that particular batch. And there I do the live sessions. I'm still doing that. But I've not brought it into the larger community and membership yet. It might happen maybe in a few months when I'm launching the third level of membership. There I may do the boot camps where there'll be live training plus the bootcamp part. But right now, no. Right now, I'm just doing these live sessions every week. There'll be weekly live. I plan to do that, continue to do that for the members here on, and that will remain like something like this. But do we do it in more like a elaborate workshops or not? That I haven't come up with at least yet right now, except for my corporate batches. I do that for corporate trainings, which is like my bread and butter right now. But I haven't brought it into the membership yet, at least yet, not yet. Might do it in future, but not for the next 3-4 months, for sure.
Got it. Thanks.
Okay, Gaurav, just last thing. So do you have any documentation where you would have demonstrated Helm chart with ELK stack?
ELK, I think there is monitoring part, which is part of my Helm demonstration, which is more like Prometheus and Grafana. Yeah. ELK, I haven't gotten to the Helm plus ELK yet, so it's not there yet, actually.
Understood. Okay, sure.
Yeah, but you can look at, if you have Helm, right, you can look at artifact.hub.io, right, where you find the Helm charts, and you can.
I was trying to do that, but what happened, like at the last step, I'm creating a VM, the Kubernetes cluster, let's say in a Linux VM, but somehow port forwarding, and I'm not able to access the UI, the Kibana part at the end.
Check the service type. It may be load balancer, and you may have to change it to node port or something. So try to change the Kibana service to node port, and most likely that would work.
Okay, sure. I'll look into that.
That's my tip to you. So just give this a try, right? So that might work.
Sure. Thank you.
All right, perfect. So let me also share the link to the Discord with all of you here. I think that would be helpful maybe. So in case if you're joining the Discord community, it is not as active as I wish it would have been yet, but we will initiate the community as well. So that would happen. Again, I'm moving to a newer platform where there would be a lot more interaction built into the learning itself, right? So that's what we plan to do. So here goes the Discord link. in case any of you want to join that Discord community right now. There it goes. All right, so thank you. And we are a wrap here. And I'm going to see you next week with the mission number 8, where we'll be talking about the ingress controller. Stay tuned. And you will receive the email communication with that probably by Tuesday or Wednesday. All right. Thank you, and have a great weekend. Week ahead, weekend, and I'll see you next week. Bye.
Thanks, Gaurav.
Thank you.
Thanks a lot.